In 7.5, we're going to talk about multiplying polynomials. So our essential question, how do we multiply polynomials? And we're going to learn a couple of strategies. We're going to focus on using the distributive property and using the area model or the box method, or I also like to call that method the punnet square method because it ties back to biology and something that you may be doing right now or may have just finished doing in biology. But before we jump into these two methods, one thing that I want to point out from the very beginning is that unlike when we're adding and subtracting polynomials and the exponents don't change, we are multiplying here, which means that our exponents will change. If you remember, at the very beginning of this unit, we talked about multiplying x squared times x to the third, and we said, what does that mean? It means I have x times x, and I have x times x times x, and this did in fact change to become x to the power of 5. And even on a more basic level, if I was counting how many things I have, that total would be the number of that item that I have. But when I'm multiplying, what I'm really doing is I'm resizing, thinking about like a photograph. If I was multiplying the size of a photograph by 1.5, I'm changing what it looks like. So it should make sense now that our exponents are in fact going to change when we are multiplying with our polynomials. So the first method we're going to talk for multiplying is called the distributive method, and you should be comfortable and familiar with that word. And what I mean by that, what would happen, so here we have the product of the two binomials, 2x minus 1 times the binomial x plus 4. But if I just covered up this minus 1 for a minute, I just made it go away, and I just had 2x times the binomial x plus 4, we actually did this earlier on in Unit 1. We multiplied something by a binomial, and when we did that, we just distributed, and we said that we would multiply 2x times x and 2x times 4, and that would give us the product of those two things. And that's actually exactly what we're going to do now, except we're going to do it twice. We're going to take this 2x, and we're going to multiply it by x plus 4. So you can see that right over here. We're going to take 2x and we're going to multiply it by x plus 4. But we can't just ignore the fact that there is actually a negative 1 here. So we're also going to take negative 1 and we're going to distribute negative 1 to x plus 4. And that product is happening here. So we're just multiplying 2 times. Both times we're multiplying one term in the first binomial or the first polynomial by the entire second polynomial. So what I want you to notice is that when I write this out, I actually have x plus 4 here twice because x plus 4 needs to get multiplied by both of the items or both of the terms in the first binomial. So let's go ahead and do this. Let's distribute here. 2x times x and 2x times 4, that's going to give me 2x to the second power plus 8x. Negative 1 times x is negative 1x. Negative 1 times 4 is negative 4. And now I have a polynomial with some like terms that I can combine, which are right here. These are my only like terms. So I'm going to make sure my answer is in standard form. 2x squared. 8x minus x is going to be plus 7x minus 4. So this product of these two binomials, 2x minus 1 times x plus 4, is 2x squared plus 7x minus 4. So before I talk about the second method, let's just look at what we just did and let's apply it to another example. So I need to multiply x times x minus 5, x times x minus 5. And I also need to multiply positive 2 times x minus 5. So I'm taking each term and I'm distributing it to the second set of parentheses. So let's go ahead and perform that distribution. X times x is x squared. X times negative 5 is negative 5x. 2 times x is 2x. 2 times negative 5 is negative 10. And then we can go ahead and combine like terms. So that's going to give me x squared, negative 5, positive 2 is minus 3x, minus 10. So this method is called the distributive method because that's exactly what you're doing. You're distributing multiple times and then combining like terms to write a simplified expression, a simplified polynomial in standard form. There's another approach to take to this called the area model or the box method, or as I said, I like to sometimes refer to it as the punnet square to tie it back to biology. And you're going to do the exact same thing, but it's just visually going to be set up differently. So let's take this same problem, 2x minus 1, that's in this top box, times x plus 4, and let's do it using the area model. So I'm going to take one term and I'm going to write that term across the top, or one polynomial. I'm going to take the red one and write that across the top, and one polynomial, and I'm going to write that across the side. Now, just like with the punnet square, what you're doing is in each box, you're going to multiply the two things that come together in that box. So what I mean by that is in this first box here, what am I multiplying? I'm multiplying x by 2x. In this top right box, what am I multiplying? I'm multiplying 2x times 4. In this bottom left box, what am I multiplying? I'm multiplying negative 1 times x. And in this bottom right, negative 1 times positive 4. So I want you to see where these things are coming from. And on this first time, I'm just going to write everything in the box together. So this is 2x times x. This is 2x times 4. This is negative 1 times x. And this is negative 1 times 4. And then if I actually simplify this, this is 2x to the second power. 2x times 4 is 8x. Negative 1 times x is negative x. Negative 1 times 4 is negative 4. And just like we had to do with the distributive method, we're going to rewrite this and combine like terms. So 2x squared, and I want you to see I actually have like terms in these two boxes. 8x minus x is going to give me positive 7x minus 4. And you should notice that these two polynomials are the same. So we got the same answer using two different methods. And what I really want to focus on in these notes is going back and forth between the two methods so that you can kind of decide which method you are more comfortable with. Okay, let's go ahead and look at number 2. And for this one, let's use the area model or the box method. So I'm going to take one of the two terms I'm multiplying together, or one polynomial, 2x plus 3. I'm going to write it across the top. I'm going to take the other polynomial, and I'm going to write it across the side. It doesn't matter which one you write where, we're multiplying. All that matters is that you keep each specific polynomial together, meaning I can't write 2x and 5 both on the same side. I can't write 2x plus 5 both on the same side over here because 2x and 5 don't go together. 2x has to go with 3. So inside the box, we're going to multiply the two things that we would get. So inside this first box right here, I need to multiply x times 2x. Well, that's going to give me 2x to the second power. In this next box, I need to multiply x times 3. That's going to give me 3x. In the next box, I need to multiply 2x times 5. That's going to give me 5x. No, silly me. That's going to give me 10x. 2 times 5 is 10. And in the last box, 3 and 5, which is going to give me 15. Now, you can't leave your final answer in the box. You need to rewrite it as one polynomial term. The box is just sort of a graphic organizer to help you multiply. And the thing that a lot of people like about the box method is that you know you've gotten everything because your box is full. You're not missing a term. You didn't forget to multiply anything because each of the boxes is full. So now let's make sure we combine like terms. 10x and 3x is going to give me 13x when I combine those. So let's rewrite our final answer. 2x squared plus 13x, 10x plus 3x plus 15. That is what I get, the product of 2x plus 3 times the binomial x plus 5. Okay, let's look at some more examples. Let's work through number 3 together. And on number 3, let's not use the box method. Let's just simply use the distributive method. So I am going to distribute both of the terms from the first polynomial, y plus 4, to the second polynomial, which is y minus 1. So what I mean by that is I'm going to multiply y times the binomial that I'm multiplying by, y minus 1, plus 4 times that second binomial I'm multiplying by, y plus 1. Then I'm going to distribute. So y times y is y squared. Y times negative 1 is negative y. 4 times y is 4y. 4 times negative 1 is negative 4. And then I'm going to rewrite the final answer combining those two like terms in the middle. That's going to give me y squared plus 3y, since negative y plus 4y is going to be 3y, minus 4. And this is going to be my simplified product, what I get when I multiply those two binomials together. For number 4, let's go ahead and use the box method. So pause the video and see if you can set up the box on your own. Okay, so here on number 4, I have set up that box. And if you're thinking, oh no, my 2r minus 1 is on the top of the box and my r minus 5 is on the left-hand side, that's okay. Don't erase. You haven't done anything wrong. And you're going to see that your final answer should end up being the same, even if you haven't written it the same way that I have written it here. So remember, in this first box, top left box, 2r times r, which is going to be 2r to the second power. In the next box, 2r times negative 5, which is going to be negative 10r. In the next box, negative 1 times r, which is going to be negative r. And in the bottom right, the last box, negative 1 times negative 5, which is going to be positive 5. Then I'm going to make sure that I combine like terms, and I have two of them here diagonally. So I have 2r to the second power. Negative r and negative 10r is going to give me negative 11r plus 5. So the product, or what I get when I multiply the binomial r minus 5 times the binomial 2r minus 1, is 2r squared minus 11r plus 5. Now I want you to look at number 5 and ask yourself, something looks different. What looks different about number 5 from all the other examples that we have done so far? Ask yourself that question. And I'm hoping that you realize what looks different is all of a sudden we're not multiplying two binomials together anymore. We're now multiplying a binomial by a trinomial. That's right, that second set of parentheses has 3 terms. It is a trinomial. Now, how is that different? So I'm actually going to do both methods on this problem. Let's see if I can fit that. So our first method really isn't different at all. If I'm using the distributive method, I'm going to say 2x times x squared minus 3x plus 4 minus 1 times x squared minus 3x plus 4. And I'm still just going to distribute as I have done before. 2x to the third minus 6x squared plus 8x minus x squared plus 3x minus 4. And then last but not least, I'm going to combine terms. So combine like terms. 2x to the third, negative 6x squared, and negative x squared is going to give me minus 7x squared. 8x and 3x is going to give me plus 11x. And then nothing is combining with minus 4. So that's going to give me my polynomial there. Now, some of you might already kind of get the feeling that you like the box method better, and that's totally fine. And if you do like the box method better, think about how could I use the box method on a problem like this. So I'm going to temporarily cross off number 8. We'll come back and do that one afterwards. So the only difference here is that now your box is going to have some more spaces, and you could also draw this box this way where the 3 is going down. Totally fine either way. Just making sure that you set it up correctly. And what I mean by that is you're going to have your 2x and your minus 1 on whichever side only has 2 spots. And you're going to have your x to the third, x squared minus 3x plus 4 along the side of the box that has 3 spots. And the same process holds. 2x times x squared is 2x to the third. 2x times negative 3x is negative 6x squared. Here I have 8x. Here I have negative x squared, positive 3x, negative 4. And there will still be like terms that can be combined. Here is a set of like terms, and here is a set of like terms. And if you combine all of those things together, you're going to get this exact same answer that we just found. So I'm not going to do all that work again. But 2x to the third minus 7x squared plus 11x minus 4, we're going to get the same answer either way. So the box method still works even if you're multiplying by a binomial by a trinomial, or even if it was a four-term polynomial by a four-term polynomial. And that would be a lot of space and a lot of boxes to draw, but you could still set it up in this way. Okay, what I'm going to encourage you to do right now is pause the video and work through 6, 7, and 8. And that might just be that all you can do is set it up and maybe decide which method you like better. It could be that you can get about halfway through, but work as far as you can get on each problem and then unpause the video and see if you can work through it with my help. And if you can work through the whole thing without my help, that is awesome. Just make sure you keep watching the video to see that your answers are correct. All right, here we go on number 6. I'm going to do number 6 using the distributive method, and I'll do number 7 using the box method. So p times p plus 2 is going to give me p squared plus 2p. Negative 8 times p plus 2 is going to give me negative 8p minus 16. And when I combine like terms, p squared minus 6p minus 16. Number 7, I'm going to go ahead and set up using the box method. So here it is set up. I decided to put 2x plus 1 on the top and 3x minus 2 on the left. If you set it up the other way, that's okay. 2x times 3x is 6x to the second power. 3x times 1 is 3x. Negative 2 times 2x is negative 4x. Negative 2 times 1 is negative 2. And I'm going to rewrite my final answer in standard form, and I'm going to combine like terms here. Negative 4x and positive 3x is going to give me negative x. So 6x squared minus x minus 2. And last but not least, number 8. I'm going to do the box method on number 8, but the distributive method would work as well. And maybe I'll actually move this up and do it both ways just so that you can see. But pause the video and really try and see if you can get through this one on your own. So here I have set up my box. N squared times n is n to the third power. 2n times n is 2n squared. Don't forget, when in doubt, expand it out if you're getting stuck. Negative 5 times n is negative 5n. Negative 3n squared. Negative 6n. Positive 15. And then I am going to have some like terms that I can combine. So I'm going to rewrite my final polynomial, n to the third minus n squared minus 11n plus 15. So the highlights from this section of notes, the things we don't want you to forget. The whole goal of this section was that you understand how to multiply polynomials, and hopefully that you're starting to get comfortable either with the distributive method or the box method, or maybe both. But remember that what you're doing is multiplying two polynomials together, and that is in fact going to change the exponent values. So whether you're distributing or using the box method, multiply, combine like terms, and rewrite your answer in standard form. If you have any questions, make sure you write them down so we can address them in class, and I'm looking forward to supporting you there. Thanks for listening.